So this video is going to be more examples of how to find the inverse of a function. If you haven't seen the video 2.5G, you should watch it because it's the introduction, the first example of finding an inverse, and some books call it the switch and solve method. We're going to continue to do that, use that method here. The very first step in finding the inverse of a function when we have an equation excuse me, is we're going to take out the f of x and replace it with replace it with y. So first of all, take out the f of x, replace it with y. Okay, so now we haven't gotten an inverse, we haven't done anything but just rewritten the f of x. So now we're actually going to take the inverse. We're going to switch the x and the y. Okay, and now this last step is going to be to just get y alone. We're getting y alone. So we have 2y on the right, we have x plus 3 on the left. I'm going to continue to get the y isolated. I'm going to move over here, and I have y on the right is equal to x plus 3 over 2. Now, I know that you know that this is the same thing as this, right? I can take that 2 in the denominator and give it to both terms. It's the same thing. And so what I'm going to do is I'm going to rewrite this way. 1/2 x, because that's the same as having 1/2 of x. X divided by 2 is 1/2 of x plus 3/2. Now, the reason I did that is this looks like a line, and it is. Well, this is also a line. Well, it makes sense that the inverse of a line would be a line, as long as it is invertible. Okay? Alright, let's take a look at the next one. We're going to take out the g of x and replace it with a y. Now this time we have x in 2 locations, but we still need to switch. So we're going to switch and cause that to be x equals 3y plus 2 over y minus 1. Now we need to get y alone, and at this point y is both in the numerator and the denominator. I'm going to need a fraction on both sides. I want to make my x into a fraction. The reason is because now I want to use method called cross products. So I'm going to multiply the denominator of one side times the numerator of the other side, and I get this 3y plus 2 on one side of the equals, and then I'm going to multiply across the other way and get x times y minus 1 on the other side. So look at the colors there and convince yourself that this is just us using cross products and the distributive property. Well, actually, we're about to use the distributive property, so let's go ahead and continue. I have 3y plus 2 is equal to xy minus x. Now, this is a little bit tricky in that we have y in 2 locations. That means that I'm going to need to get the terms with y in them on one side. I'm going to say that again. I need to get the terms with the y in them on one side of the equals, and everything else needs to go to the other side. So let's take a look. I'm going to move my xy term over here. Okay, so that's 3y minus xy plus 2 is equal to negative x. And now I'm going to move my 2 to the other side because it's not a term with y in it. Okay, so convince yourself of what we just did. We moved this term to the other side, and we moved this term to the back to the right. And so now we have all of our terms with the letter y on one side. Now, why is that helpful for us? Because I'm trying to get y alone. I'm going to come over here and finish up. I'm trying to get y alone, and I can now factor out the y it's letting me move over a bit. I can factor out the y. So now my y is in one location. So this is probably one that you'll have to practice a little bit. Takes a little bit of getting used to. A little more complicated. Now what are we going to do to get y alone? All we're going to do is divide by 3 minus x, divide by 3 minus x, and I get y is equal to negative x minus 2 over 3 minus x. Okay, now the book might factor out the negative 1. The book, some book might do that, and then take the negative 1 and put it at the bottom so it looks a little neater, and then that would be a positive x and a negative 3. I don't know. They may or may not do that, but this is the same thing as this. Okay, bottom line, it's the same thing. Okay, let's take a look at one more example. Alright, first thing we're going to do is we're going to take out the h of x and make it a y. Now we're going to switch variables. Alright? Now, I need to get the y. Thank goodness it's in one location, right? I need to get the y isolated. Well, the only way I'm going to be able to get that isolated is to isolate the radical. So first thing I'm going to do is add 2 to both sides. Think about your goal. Your goal is to isolate the radical so that we can square it eventually. So I have x plus 2. Okay, so far so good. I'm getting it slowly whittled down. Now I'm going to square. That's square rooting, so I'm going to square, and that's going to undo the square rooting. And now we have y plus 3. On the other side, I have to FOIL it. That's going to be x squared plus 4x plus 4. Last step, get the y alone. And I'm finished. Y is equal to x squared plus 4x plus 1. So let's take a quick look at some of the restrictions that we're going to have on this situation. What I'd like to do is look at the original function. Let's look at the original function here and look and see what restrictions we have on the domain. We can't take any numbers smaller than negative 3. We can take negative 3 because when I put a negative 3 in, I get the square root of 0, which is 0. I get negative 2. I can put a negative 2 in there. In other words, anything larger than negative 3 is going to be fine. So let's get some numbers that will be helpful for me. I've got a negative 2, that's going to be 1. That's negative 1. I put a 1 in there, I get the square root of 4, which is 2. Minus 2 is going to give me 0. So I can continue to get larger and larger here, right? And I'll continue to get valid y coordinates there. Now, because the domain of the inverse has to be the range of the actual function, okay, then I have to limit my x values, okay, because the domain of the inverse has to be the range of the function. I'm going to have to limit my x values on my inverse. So let me finish this out by saying this is how we're going to write it. I think I forgot to do this notation on the last one, but this is my h inverse, right? That's my h inverse. Last step is to go back and switch from the y to the function notation. So there's my inverse, but here's the restriction. X has to be greater than or equal to negative 2. Okay, so we have to put that restriction in, otherwise it's not going to work because the domain of the inverse has to be the range of the function. Alright, thanks for watching.